Okay, after slightly botching number 7, notice this one we're using graphing technology to find the real roots to two decimals. I think it just wants you to practice with your graphing calculator. And you know what? A graphing calculator also stores a formula. I highly encourage you to learn how to store the formula into the graphing calculator, and that'll allow you to find values of f1, f2 very quickly. And if the result is 0, you'll know that this is a root. So it's a lot faster than the method I'm doing on here, but here I'm trying to show you the tangible way of doing it instead of letting a machine do it. But in this case, when they say use a graphing calculator, I'm not going to plug them in for all because there's no point you watching me plug into a calculator. You just simply make sure you have all the terms on the same side. So this, for instance, you either bring all these terms to this side to keep x to the 4 positive, or you put all the terms to the left side, and you just make sure all the terms are on the same side and is equal to 0. Now if you put that into a graphing calculator, it's going to give you vertical lines showing you where the x-intercepts are. It's actually easier to make it equal to y, because then it's going to show you the graph, and wherever the graph crosses the x-intercept, you will find the roots, the real roots. It's the opposite, or what the exact x-intercepts are. And just be aware how many times it can cross the x-axis is based on its biggest term. In this case, that's its biggest term. That's its biggest term. That's its biggest term. And that's its biggest term. So that's how many times it can cross the x-axis. And then 1 minus its biggest term, n minus 1, is how many turning points it can have. So that's a turning point. That's a turning point. And just remember the behavior. All cubics that are positive leading coefficient start in quadrant 3 and end in quadrant 1, and can cross up to 3 times with 2 turning points. All quartics start in quadrant 1. They can cross down sometimes into the other quadrants, but they always start in quadrant 2 and end in quadrant 1. And then anything to the power of 5 is very similar to the power of 3, except it can cross 5 times. These behaviors dictate where the x-intercepts are going to occur. So I'm only going to put this first one in, x cubed minus 7x plus 6. And I'm going to make it equal to y, because if I make it equal to 0, I get these things, which tell me the roots, but not as clearly. So I just make it equal to y, and I can see that one of the roots is minus 3, the other root is 1, and the other root is 2. Just be aware that root, or zeros, are the opposite of factors. So that would be x plus 3, x minus 1, x minus 2. And I'm not going to do it for each of them, but that's what you do, and it's good to notice the behavior of it and make sure you're able to anticipate. Notice that where it crosses the y-axis is right there. And all these things help you learn how to graph it. So just do each one. Make sure you get all the terms to one side. Make it equal y instead of 0. And you'll be able to come up with it. These next ones are just synthetic division. And there's nothing special about them. They just want you to be able to solve it. Now, I also strongly suggest you just put this into your graphic calculator with f of x is equal to, or your formula into your scientific calculator, and just do f of 1, f of 2, f of 3. And if it comes out 0, you know you've found a root. So this one, I can almost say for certain that these numbers are so small that 1 is not going to do it. And I'm going to start right away with 3. I just done a hunch. So the numbers we're dealing with are 1, minus 6, minus 1, and 30. Notice you have the y-intercept there right at 0, 30. I'm going to start right away with 3 just because of a hunch. So I'm dealing with 1, 3, minus 3, minus 9, minus 10, and sure enough, minus 30. So that means that's one of the roots, 3. So x minus 3 is one of the factors. And I can see right away when I'm dealing with x squared minus 3x minus 10 that the factors are x minus 5 and x plus 2, which will produce a minus 10 and a minus 3x. And there you go. That first one was fairly quick and fairly fast. And you can see that you can do it quite quickly with synthetic division. This one's similar. I can see that there's something going on, but the first thing you want to do is factor out an x, because they all have x in it. So that means it's not the only y-intercept is going to be at 0, 0. And I'll be left with 9x cubed minus 42 plus 64 and minus 32. And just remember, it's going to be one less term here once I factor the x out. So I'll just put the x aside as one of the factors. And now I'll work on these, knowing it's now x cubed. And I'll just start with, it's going to probably be more than 1, but we'll try 1. So minus 33. Close. Very close. Try minus 1. Oops. That's 9. Times minus 1 is minus 9. Minus 51. I can see it's not going to work out already. 51. I'm left with 105 here, so that's not going to work. So let's try 2. What is that? 16? Oh, that one works. There we go. So that means my next factor is x minus 2. And I'm left with 9x squared minus 24 plus 16. So it looks like long, hard factoring. So I'm dealing with finding a number that multiplies out to 135 and adds up to minus 24. Oops, I got the 135 wrong, rather. It's not 135. It's going to add up to 144. Now, because this number is quite large, it means the two factors I'm looking for are quite far apart. So they're not. It's not going to be close to 12 and whatever. 12 and 12. Oh, I might have hit it right there. Because this is plus and this is minus, we are indeed talking about minus 12 and minus 12. So there you go. However, you have to use the slip and slide method, which means I'm dealing with x minus 12, and obviously it's squared, but I'm just going to leave it like this. Okay, and when you take the number in front and put it to 9 divided by 9, those both can be simplified to 4 over 3. So I'm left with x minus 4 here, and then the 3 just slides in front of the x. So the factors I'm actually dealing with are 3x minus 4, 3x minus 4 squared. Sure enough, if you were to expand that, you'd get 9x squared minus 24x plus 16. So that means its roots are 4 over 3, 0. This root here is 2, 0. And this root here is 0, 0. So you could graph it, and notice that this is squared, which means that if I'm going to graph it, I'm dealing with a quartic. It starts in this zone up here. It's going down to here. And 4 over 3 is 1 1/3. So it's going to come down. It's going to go through 0, 0. When it comes up to 4/3, it's going to bounce. That's what the square means. and then it's going to go up through 2 comma 0, and off it goes. So it's going to cross through. It's going to bounce once here, but touch at 4/3, comma 0, and then it's going to go through 2 comma 0 here, and off it goes. Okay, next one. This one you have to put everything to the same side. So it's not minus 20. You put this minus to the other side, and it becomes plus 20. Equals to 0. Notice that it's going to have a y-intercept of 0 comma 20. It's a quartic. The numbers we're dealing with are 6, minus 13, minus 29, 52, 20. They don't fluctuate much, so definitely check out the 1 first. Close. So close that I want to check my numbers again. Oh, that's minus 7 over here. Close. So I'll check minus 1. For the same reason, it's quite close. No. So probably in the 2 territorial. Got it. So that means x minus 2 is a factor. And I've left with 6x cubed minus 1 minus 31x squared here, x there, and minus 10 there. So those are my new what's left. And you start with those as coefficients you're going to deal with. And we just checked 2, so we should check minus 2 as well. And you can possibly have 2 twice as well. Just out of curiosity, we're going to check 2 twice. No. And we're going to check minus 2. Got it. So that means x plus 2 is a factor. And you're left with 6x squared minus 13x minus 5, which means we're looking for something that multiplies out to minus 30. and adds up to minus 13, which is clearly, oh, I thought I had it there. Minus 30 and adds up to, I almost thought it was minus 3 and plus 10. It's not. And I don't know if that's factorable, if I got the factors wrong. Let's see. No, I got the factors right. So plus, 6 minus 5, no. Minus 30 plus 10, no. Minus 10 plus 3, no. And there's nothing else really works after that. So that means you'd have to do the quadratic equation, I think. Let me just cheat a little here and go to 9. Am I on 9? Yeah, 9C. Oh no, it's solvable. I'm just not seeing it. Okay. Oh, I'm an idiot. Minus 15 plus 2. Jesus Christ. In this case, you have to do the slip and slide again. And when I put a 6 under this, it becomes a third. So that means this last one is 3x plus 1. When I put a 6 under the other one, they can both simplify to 5 over 2. So I'm talking about 2x minus 5. And just to make sure you got the right ones, keep in mind you're trying to get 6x squared here. I get 6x squared plus 2x minus 15x, which makes minus 13x minus 5. So indeed, I get it. So there you go. That's the last factors. That one. So we're down to the last one. It's a quartic. Notice that things aren't necessarily on the right side here. When I bring the x squared, negative x squared here, I get 9. And when I bring the plus 2x here, these wipe each other out. So that means this gets replaced with a 9. And these disappear. It's equal to 0. Which means I'm dealing with the coefficients 1, minus 6, 9, 0, and 0. Let's start with 1. Nope. Start with minus 1. I think unless it wipes out the 9, it's not going to work. Go try 2. Nope. It looks like it's going to be a half or something like that. Try minus 2. We'll try 3. Which I should try all along because of the 9. There it is. So you might say, what the heck is that? That's 1x cubed minus 3x squared. So that means x minus 3 is one of the factors. But I'm left with x cubed minus 3x squared. And of course I should have realized that I can factor out an x squared in the beginning, because look up here. I could have just started with that and factored out an x squared. I just was being stupid. And I'm left with that. I'm left with x minus 3. So it looks like it's x minus 3 squared and x squared. And I think those are the two factors. Just to make sure I didn't screw it up. Yeah, they're just given the roots in here, even though they asked to solve it, which would be factoring. But yeah, they're just giving the roots. So the roots here are 0 and 3. Graphically, it's a quartic. It's going to come down. It's going to bounce off 0, 0, go up, bounce off 3, 0, and then go up. And it's going to cross the y-intercept. I don't think it had a number, so it's just going to go through 0, 0. Number 10. So they start doing word puzzles, and a lot of students hate word puzzles, but you just got to eliminate or include everything they tell you. Now a lot of tests won't include the nice diagram, but essentially you're cutting out these corners, and you're calling those squares, so they have the dimension x by x when they're squares. And then you're creating this little fold pattern, and you're folding those flaps up, and you're creating this box, which has a length of, the full length is 30, but you have to subtract 2 x's. So that's how they get 30 minus 2x. The width is here. The full width is 20, but you have to subtract 2 x's. So you get 20 minus 2x. And of course the height, when you fold this flap up, it's x high. So it helps to really understand how to transfer words individuals. So you start with a piece of cardboard, 20 by 30. Then you cut out corners, square corners, x by x. And then you got to determine the dimensions that are possible to give you 108 cubic. So once you determine the dimensions and you realize volume is length times width times height, you get a possible formula. Okay. Now let's ask ourselves, if one of the sides is x is 20 minus 2x, right? What values of x will make this impossible? Well, you can't have a 0 dimension, so 20 minus 20 is impossible. So if you set this to equal to 0, you discover 2x is equal to 20, x is equal to 10. So that means you can't go past 10 for x. X has to be bigger than 0 and smaller than 10. Because if it's bigger than 10, or 10 or bigger, this becomes 0. If it's 0 or smaller, this becomes 0. And you can't have a 0 dimension on your shortest side. And we use the shortest side to determine the max value of x. So we know that x must fall between 0 and 10, and that's an important distinction. So we're left with this as a formula. Length times width times height. There you go. To solve it, we have to expand. Let's expand the first x first. Actually, let's expand the numbers first. What's minus 60x and minus 40x? And then plus 4x squared. Now we're going to multiply all this by x. And this becomes x squared, and this becomes x cubed. Which is clear to me that you're dealing with the cubic, 4x cubed minus 100 x squared plus 600, and you're trying to make it equal to the volume because the left side is the volume formula, and you're trying to make it equal to this, which means if I adjust the whole thing, by the way, this is a cube, this is a square, if I make the whole thing equal to 0 to solve it as a quadratic formula, I'm left with this minus 1008. And that's all I'm doing is putting this on the left side of the formula because you have to equal 0 to solve it. Okay? So there's our starting point. We have a cubic equal to 0. We can see this number is getting huge. So it's going from 100 to 600 to 1008. So we're probably talking about like a 3 or a 4 as a factor. Let's use synthetic division to solve it. We're talking about 4 minus 100. I'm just using the coefficients in front like we do for all of them. So in case you didn't understand, we came up with the dimensions of a box based on criteria. We know there's a limit on the x values, and we know that volume is length times width times height. Since we have all of those, I multiplied them all times each other, and we know we're trying to achieve a volume of 1008. Then I just do this so that I can solve it as a using synthetic division, finding its factors. So I'm going to start with 1. I can see right away that 1's not going to work, just because the numbers aren't becoming big enough. 2 might, though, look, because of the 504 here. So we're going to try minus 1 just to make sure. 4 minus 104, 104, 704. Nope. So we're going to try 2. Almost. Didn't quite make it. We're going to try minus 2. And because dimensions are positive, I'm really always going to be working with a minus root. No, I'm only going to be working with a positive root. So I know that minus 2, well, it might be a factor, won't actually be a dimension I can use. We'll get into that in a second. Nope. So positive 2 and negative 2 are out. We're going to go on to 3. Four, 264, I think. So you got 316. I think this is really close, so I want to make sure I got my subtraction right, and I didn't. And when I multiply that by 3, I indeed get 108, which means one of my possible dimensions is 3, which is great. And just make sure I got my right numbers, and I do, which means x minus 3 is a possible answer. In that case, x would be equal to 3. And remember that they did say determine the dimensions, so we're not done yet, which is solving for x. Now I'm left with what's really a cumbersome quadratic. The first thing you can do, which I should have done in the very beginning actually, is factor out a 4. Actually, I can't factor out a 4. Let's factor out a 2. Oh, no, I can factor out a 4, sorry. Squared. And then when I factor out 4 here, I get 8, 16, 32. So I got 8 and 4. I think that's it. 68. Yeah, that's it. This is squared here. So and I can actually factor out a 4. Which means there's a 4 in front here. And I'm left with this. And I can get rid of all that. I'm left with that. So I'm looking for a number that multiplies out to 84, but adds up to minus 22, which means the numbers are going to be quite a ways apart. 42 and 2 doesn't work, so I'll half that. 21 and 4 doesn't work. So right away, I have a sneaking suspicion that this is not factorable. So I'm going to pull out my quadratic equation function calculator, which you can find on the internet, by the way, but you can also make one with Excel, and you can also create your own on your calculator. That's 22 and 88, I think. What's the last one? 84. Calculate. And sure enough, these are the two possible x values down here. Remember that the quadratic formula will calculate the roots themselves. So you don't have to, and it was indeed not factorable. So this tells me that x is equal to 17.008, or x is equal to that. But remember our original limitations due to the dimension not being able to be 0. I must only use values of x that fall between 0 and 10. That's because anything more than 10 will negate this side, and anything smaller than 0 is not a dimension. So that means this one's right out, which means the possible values for x are 3 or 4.9. How many, okay, we'll just do 972 centimeters, right? Yeah, centimeters. Okay. Which means that height is equal to 3 or 4.9172 centimeters. Length is equal to 30 minus 2 times 3, 6. So 24, or 30 minus 2 times 4.9172. What was it? I'll just copy it directly. For that. And width is equal to 20 minus 6, which is 14. Or, I should have an or in here, or 20 minus 2 times 4.9172 equals, or this. So these are the possible dimensions. And if you were to multiply them out, for instance, if I multiply all of these, I should get my original volume of 1008. If I don't, I did something wrong. So I'm just going to round up a bit just to save myself some time. And I'll expect a rounding error. It's just to see if I've got them roughly close. Yeah, it's close enough. I'm going to now take it to all the decimals just to make sure. And keep in mind that as I created each one, I created a rounding error because I didn't take them all. There you go. Pretty certain I got the right stuff. So be aware that these decimals create rounding errors that doesn't produce your exact dimension. So you should actually keep it in the format that like this. Since we know it can't be plus, that would create the 17 dimension. We know the only valid other answer is that. When you keep it like this, you're keeping it exact. You're not getting all those rounding errors from the decimals. This is why people in mathematicians like to note things to leave it like this, because this is an exact number and this is not. So that's one of the possible dimensions of x, and the other dimension of x we discovered was 3. Then you plug all those into your original height and width formulas to discover the other dimensions. So let's see if we got it right. Yeah, there it is there. They only give the x value. Oh, they only wanted the dimensions of x, did they? Yeah, determine the dimensions of the squares. So they were saving us some time, but I'm glad I showed you the other thing because some questions will ask for all the dimensions. But yeah, they're only giving us the dimensions of the x corners. 3 by 3 or 4 by 92 by 4 by 92. So make sure you answer the question asked. I should have read here, determine the dimensions of the squares, which are these ones in the corner. All right. Always play, you can play these things at double speed, by the way, if you don't need the details I give. But I like to give the details, always answer the question at the end. So for the last question, you would have always taken what they asked at the end, and you would have said, the dimensions of the squares are either 3 by 3 centimeters or 4.92 by 4.92 centimeters. The third dimension of 17.6 by 17.6 is not a possible solution. And you can just, if you put that in there, you get, bonus points. He knows that you've discovered it if he doesn't look at your work. Okay, so the family members are very competitive card players. They keep a score using a complicated system that incorporates positives and negatives. My score for the last game would be modeled as this. So they give it in the factored form, but only for x is smaller than 10. So anything above 10, they don't care. It's not relevant. After which game was my score equal to 0? Well, that's whenever any of these brackets are 0. So we can see that my score was 0 when x was 0. So at game 0, which makes sense. At game 4 and at game 6. Also be aware that this is a cubic. It's coming up through 0. It's coming down through 4. And going back up through 6, 0, 4, 0. And then it's going onwards, and at this point here, at game 10, we stop using it. Now I want you to notice that Maya's games are negative here. So she's losing there. And she's winning here and between 6 and 10. So she's winning. After which game score was Maya's score -5. Well, that's more interesting. So we can see that -5 occurs somewhere in between 4 and 6. Now, since we count games as 1, 2, 3, 4, 5, and since we know 4 and 6 hit 0, it's safe to say, since this is the only negative zone, that 5, and this is where having it a graph helps us realize that since we're talking about even games, you don't have a 4.6 game, we would plug 5 into here. So we get 5, times 5 minus 4, which is 1, times 5 minus 6, which is minus 1. 5 times 1 is 5, times minus 1 is minus 5. So that helped us solve that without suddenly doing a weird, we'd have to expand it, we'd have to make it equal to minus 5, we'd have to bring it to the other side and use synthetic division, which I think is what they were going for. But, I mean, logically, we could figure that out from this. But I'll go for it. 16, it's pretty certain between 1 and 4 it doesn't climb to 16. However, there's a possibility. And I might as well use this question to show what they were probably going for. This is Maya's game formula. And they're saying, the first question they said when is equal to minus 5. So you'd make it all, you'd expand all the left side, and then you'd bring minus 5 to the right side and make it plus 5. Like that, and you'd make it equal to 0. But I'm not going to do that for that one because logically we solved it. But I will do it for the next one. And they're asking when her score will be equal to 16. So we're going to expand these numbers. And I get x squared minus 10x plus 24. And when we multiply by another x, we get x cubed times x squared plus 24x. Then we bring the 16 to this side, and we set it equal to 0. Now the reason I'm doing it this way is I suspect there's probably two situations where her score is 16, and that's before game 4 and after game 6. So we have to, since we know it's going to be between 0 and 4 and 6 to 10, we would only use these as roots. So we would start with root 1. We first get all the coefficients down. And we're going to start with root 1. And I should only use positives because I don't care about the negative games. I only care about her positive games. So I should only use positive roots to figure out if it all works out. Almost. So much so that I'm going to make sure my math. Yeah. Okay. So I'm going to jump right to game 2. Got it. So game 2 is one of them, which means x minus 2 is one of the roots. And I'm left with the quadratic x squared minus 8 plus 8. Now that's not solvable. Because there's no way to come up with something that multiplies to 8 and adds up to 8. It would have to be 9, like minus 9. 2 and 4 doesn't work, whatever. So that means you'd put this into a quadratic solution, which means it's going to come up with a decimal like 4 point or 3.2, which isn't realistic. It means somewhere between game and 3 and 4, Maya's game score was 15, but you can't have a game 3.28. We're going to do it anyway. We're going to use our quadratic formula. We're going to punch in 1, minus 8 and 8. Was that it? Yep. We're going to calculate, and we can see that, as suspected, we get these as possible answers. Which means at game 2, game 1.1715, and game 6.8284, Maya's score was 15. But we can see that it's not possible to have a game 1.17. She plays game 0, 1, 2, 3, 4, 5, 6, whole numbers. So, I mean, somewhere between game 1 and 2, her score was 15, and somewhere between game 6 and 7, her score was 2. Or her score was 15, rather. But it's not realistic. I think the only acceptable answer here is game 2. So our question is, draw a sketch, explain why this graph is not a good map model to represent Maya's score during the game night, and it's as I said, you cannot use these decimal places for the games. She only had game 1, 2, 3, 4, 5. You don't ever say, oh, it's hockey night tonight. They're on game 7.68429. So technically only game 2 did she have a precise score of 15. And we'll see what it says here. Yeah, so they only give game 2 as an answer. And this is not a good model to represent my score because the graph is only shown for real numbers, but the number of Maya's games can only be whole numbers. So yeah, you can only look at game 1, 2, 3, 4. And sure enough, here along game 15, somewhere along here, we got our information. And the only one that worked was 2. So there you go. You have to use a little bit of common sense, I guess, would be the answer. All right, we're going to go through this. We're going to try. And sometimes I'm good at these complicated ones, and sometimes I just don't care. So some of them you're just going to have to default to your professor. So we're given gravity on the height of a planet is given by this, where g is the acceleration due to gravity. On Earth, it's 10 meters per second squared. Time is seconds, so as time passes, it goes to a certain thing. There's an initial height. VO is the initial velocity, so if someone throws it. And SO is the initial height. The acceleration, so they're giving us Mars. They're giving us a g of this. They're saying find to 2 decimal places how long it take, how long, so they want time, to hit the surface of Mars if the object is dropped by 1,000 meters above the surface. So they're giving us g. They're telling us g is equal to negative 3.92, which means everywhere I see g, I replace it with that. And they're telling us the initial height is 1,000, which means I replace this formula as s of t is equal to negative a half. What was g? Negative 3.92 times t squared plus, did they give me initial velocity? Dropped. So the initial velocity is 0. Right? If the initial velocity is, if it's dropped, it's not thrown. The initial velocity is 0. So I think you put in 0 here. I hope that's right. And add 1,000. And they want to know when it hits the surface of the moon. In this case, this is the height over here, and it's based on the time. So they want to know when that height is 0. I hope I got it right. I'm pretty sure you put in 0 here because it's dropped. Let's see if that's true. So first of all, it wouldn't be terrible to multiply everything by 2 to get rid of that fraction. But instead, I'm just going to divide the 3.92 by 2, by negative 2, and multiply by negative 1. So it's going to become this. So really, we're dealing with this. Minus a half times negative 3.92. It's 1.96 t squared. Since it had no velocity, I'm going to ignore the velocity. And the reason you can figure that out is because they give you no other information here to figure out velocity. So velocity is probably 0. It's not involved. And since they say dropped, it clearly didn't have an initial velocity. So you're going to solve it like that. Did I do a mistake here? 0.9. It becomes positive think I made a mistake somewhere. I think I have to leave. We're talking about an upside down. Well, let's just leave it as, let's leave it in this form. So I get a negative half, yeah, let's leave it like this, times negative 3.92 times t squared plus 1,000 is equal to 0. When is its height 0? So I get a negative half times negative 3.92 times t squared is equal to negative 1,000 because you put it on the other side. I multiply by negative half, so negative 3.92 t squared is equal to negative or positive 2,000. I got a little problem here. I don't think they're supposed to express g-force as a negative. I think that's just supposed to be that, because on Earth you just say 10.0 meters per second squared, or 9.82 is it? Meters per second squared. You don't say negative. I think that's a mistake. Because that actually would imply that it's repelling the object. So I believe what actually we're left with is supposed to be 3.92 t squared is equal to 2,000. Therefore, t squared is equal to 2,000 divided by 3.92. Therefore, t is equal to plus or minus, but we're only interested in the plus. So we go with plus square root of 2,000 divided by 3.92. So how did I solve that? Well, I started with the equation, negative a half g, which is just a constant, t squared. We know the initial velocity is 0. We know the initial height's that. And we're looking for when it hits the ground. Since this is normally the height above ground, which they call s, we're looking for when it equals 0, which means we're looking for half g, doesn't matter what g is, t squared, that's the missing time, is equal to minus 1,000, which means we're looking for g times t squared is equal to 2,000. Since we're given g is 3.92 times t squared is equal to 2,000, we're left with what I just figured out for you. And that's why the g here is not stated correctly, because otherwise we'd be left with a negative number over here. So I think this is just a slight error in how they're expressing gravity. So let's take 2,000. We're going to divide it by 3.92, which is g. And then we're going to square root it. We're only interested in the positive. So I would suggest that we're talking about time of 2 when it hits the ground. Now you can graph this, so minus a half gt squared plus 1,000 if you want. Just put y-axis in terms of minus 5 to 1,000 to see it. There you go. And we're, of course, only can care about when x is bigger than 0. And we don't care after that. And there's, sure enough, 2.58. Now, if I put a minus here, watch what happens. It doesn't make any sense. It's floating off into space. So they've accidentally expressed g-force as a negative. G-force is a negative if for some reason a planet is repelling objects from it. And there's never a g-force that's negative. So they kind of made an error. I think they were trying to account. They forgot they already accounted for negative here. And sure enough, we get the answer we want. Let's see if what they say. Yeah, there it is there. 22.59. So I think they just kind of screwed up in how they, yeah, 20, see, rounding up, it's 0.59. think they just kind of screwed up here in expressing g-force, which I think they were just trying to create a negative parabola, a downward facing parabola when they did it. And they forgot they already accounted for it up here. Small error. You're going to find small errors in the book. Just the majority of the answers are right. Okay. Sorry, I keep clicking on the calculus. The distance of a ship from a harbor is modeled by a function. So always study your graphs first to understand what's going on. And this is why understanding the shapes of these things are important. It's a cubic, right? And it's got a negative leading coefficient, right? Okay. We're only interested in time. This is time, so we're only interested in the right side of the y-axis, because on the left side, negative x value or negative t values is negative time. We don't care. This is a distance from the harbor, so we're counting the x-axis as the harbor. And the ship is going to go away from the harbor and back. But this is a negative t curve, so it's going to start instead of here. It'll start here. We see that there's no number, so it's going to go through 0, 0. And it could go through something here first and then come up. Or it could go through 0, 0, come up, and come down. So this would be moving away from the harbor like north or south, and this would be moving away the harbor north. But the secret is first to understand what this graph is going to look like. It can either cross here or there. And it looks like they only want for the first 3 seconds, right? So that's important too. So this harbor is only, this thing is only relevant for the first 3 seconds. If we write it down, cube plus 3t squared plus 18t is equal to distance from harbor. We can factor out a t right away. We can even factor out a minus 3 right away. So minus 3t, you take out, you're left with t squared plus, minus t, we're taking out 1t, and then minus, and 6 divided by minus 3 is minus 6. So we're left with this very easy to factor number, and we're dealing with a plus and a minus. So we're obviously got minus 3t, t plus 2, and t minus 3. And it's the only possible values. So that means we're going through the x-axis at 0, 0, minus 2, 0, and 3, 0. Now let's graph that. So we're talking about a thing that's coming down. It's going through minus 2, 0. It's going through 0, 0. And it's coming 3, 0. Which means your graph is going to look like this. And since they're only concerned about the positive 3 seconds, it's clear, and remember that this is the way it is because it's a negative leading coefficient, it's clear they're only concerned about this hump here. So it's safe to say slightly to the right of 1.5 seconds, it will be the furthest away. Factor the time function, did it, right there. When does the ship return to the harbor? Right there, 3 seconds. It leaves at 0, 0, returns at 3. There's another 0 at D2. What is it and why is it not relevant? It's minus 2, 0. It's not relevant because we don't measure negative time. Draw a sketch of the function. Just did. Estimate the time that ship begins its return back to the harbor. Now the reason I say it's to the right of 1.5, which is the halfway distance between 3 and 0, is because this side of the graph, which dives down for infinity, and that's going to pull this whole center point to the right. It'd be tempted to say 1.5 is going to be the center, but because of this right side, it's going to pull the center of this to 1.5 just slightly to the right, and it's going to pull this center, which is normally at minus 1, slightly to the left because of this side of it. So it's going to be minus 1.1 or so, and it's going to be 1.52 or so. And you could get values of that by putting this into your calculator and constantly punching in 1.52, 1.51. You can also do it on Desmos. You get y is equal to minus 3t, t plus 2, t minus 3. And yeah, and then you got to do that to actually see it. And you can see the high point is right there, 1.72. It is 24 meters, slightly to the right of 1.5. And down here you can see slightly to the left of 1 will be the minimum. Any other questions? No, we got them all. But you can see that graphing it initially, remember when I just did the squiggle? Gives me an idea of what they're looking for, especially when I come down and realize they put a limitation on the domain. Happens to be a really easy factor as well. Inhales and exhales. So that means there's two swings of it. They're expressing it as a cubic, but in reality you'd express it as a sine curve. Anything that has a repeating cycle would be expressed better in a sine curve. But anyway, they're saying that this represents the volume of a person's lungs, and it's based on time. And every 5 seconds they inhale and then exhale. So that means that for the first 2.5 seconds they're inhaling, and the next 2.5 seconds they're exhaling. So that means on the graph we should see something hit between 0 and 5. What restrictions must be placed on time? Time must only be bigger than 0. And I should go look at the answers. Actually, let's go look at the answers of that ship one to make sure I got it right. Oh, that was in hours, by the way, not seconds. And yeah, about 1.8 hours after departure, they say. And they give pretty much the same answers that I gave. Okay. Now, also on the restrictions on this one, because they say it's from 0 to 5, I would suggest that 0 to 5 is the measurement of the graph, because they're clearly using a cubic, which doesn't accurately represent it beyond the scale of time we're interested in. If we look at it, it has a positive leading coefficient, right? Which means we're starting here. It's going to go through 0, 0, which I can tell because a t can factor out. It's probably going to go down here, and the next factor is probably going to be 5, 0. So if I was going to do synthetic division, I'd check out my 5 as one of the possible factors, just because they say it's a 5-second respiratory cycle. Okay, let's look at it. What restriction? 0 to 5 is the time we're looking at it. How many seconds have passed if the volume of air in the person's lung is 0.25? Would you answer this question algebraically or using graphing technology? Okay. First of all, it would help to find out the maximum, the volume at max. But let's just start with the equation. And we're going to factor out what happens when I factor out 0.027t out of everything. The first one becomes t squared. What happens when you take negative 0.27 and you factor out 0.027? In other words, divide. You get a nice minus 10. And then what happens when I factor out from 0.675 the nice 0.027? You get a lovely 25. So you can see once you factor out that number, you get a very factorable equation. So the answer to B would be, I'm going to use algebra once I simplify it. If I can't simplify it, I'm going to use graph. And I can see right away I'm talking about t minus 5 squared. It's a perfect square, which makes sense. Which means, graphically, I know it's going to come down. Sorry, come up, hit the 5-second, and bounce. And this is the only volume I'm looking at, which means at about 2.5 seconds, or 2.6, I'm going to get the max volume. So it would help to know what the max volume is at 2.6. So I get 2.6 minus 5 squared times 2.6, or negative 2.6 that. 2.6 that. So it would help to plug it in here. So I'm going to do that with a calculator. I'm going to take 2.6 as a guess, subtract 5. It's going to be negative, but it won't matter because it's squared. I'm going to multiply it by 0.027. I'm going to multiply it by the 2.6 because there's a t there. And I'm going to get this, which tells me that is the maximum, roughly the maximum, liters, 0.4 liters. I'm going to find it roughly 2.6 seconds. The question in question B, if asked how many seconds have passed in the volume of air, if person's lung is 0.25, is I'm going to have two volumes of air. It's going to be represented by this line. Since the max is roughly 0.4, 0.25 occurs about there. And it's going to occur, see 0.4 is here. And it's going to occur obviously twice, once when I inhale and once when I exhale, which makes sense. If I had roughly a good idea, I'd say it's about half of the second of 2.6. So I'm going to say it's 1.3, which is 1.3 on one side, and I'm going to say it's 3.9 on the other, which is equidistance from the peak I found. That's going to be roughly 2.6. So those are just guesses. 1.3, as I inhale, my lungs are going to be 0.25, and 3.9. Now, my answer for this is, for general knowledge, I'm going to use my algebra, because it would take a long time to set it to the volume I'm interested in. Or graphing technology will give it to me very fast. So if I want to get it fast, I'm going to use graphing technology. But to figure out exactly when this is equal to 0.525 liters, I would just readjust it so that everything is on one side of the equation, 0.027t times t minus 5 squared minus 25 minus 0.25. When is that equal to 0? You'd be tempted to think that that is a vertex representation of a parabola, but you would be wrong, and that's because this t is here. You'd actually have to expand it again, then subtract that to figure out the two values of 0. Let's do that. We're going to get back to this, and it's just going to subtract 0.25. Since we know 5 is a factor out of this, we could use, you can see why you would use graph for the precise answer, but algebra for the rough answer. We know that 5 seconds is going to be one of the factors. We know we're dealing with the coefficients 0.027 minus 0.27, 0.675, and the last one, negative 0.25. We're going to factor out a 5, or we're going to use 5 as a root. And you can see that we're going to have to do these annoying calculations each time. We're going to have to subtract 0.27 from that to get the next answer. We're going to have to multiply that by 5. And we're going to have to add that to 0.675. We can see that's going to be 0. And the reason 5 is no longer a factor, and this is where I made a mistake, is this whole graph was then lowered by 0.25. So 5 is no longer a factor. So now I actually can't use it like that. And it'd be very hard algebraically to figure out where 0.25 actually exists. So what I would instead do is I would put in the volume here, which I think I took out 0.0. What did I do? I'll bring back everything. I think I still have it in there. Yeah, 0.027t. T minus 5 squared. Here's the original graph. And actually, I found the peak incorrectly because it's actually dragged to the left. So the max volume is actually there, 0.5 liters. So you can see where graphically it helped, even right there. And then if I set a value of y equals 0.25, wherever it crosses is the time inhaling at 0.447 seconds and exhaling at 3.33 seconds. I didn't do too bad in the guess, except that I didn't realize the max correctly. The max is actually pulled far more to the left because of this. Visually it makes sense why it's pulled more to the left. And that's because it double dips here, so there's more pull on the left. So I failed to realize the max was actually pulled to the left and not the right, which made the estimate even worse, which shows why graphically this is a much better way to see where the lungs are 0.25. You could also readjust the whole graph here and subtract 0.25, and now where it hits the x-axis will be the points where the lung is at 0.25 because we lowered the whole graph by 0.25. You could, if you had another technique, because 3.33 is actually 3 1/3, so you could use synthetic division to come up with 3 1/3. It would take you a long time to do synthetic division. You'd need more advanced tools that you haven't learned yet. So the answer to that is graphically. Solve the problem. We just did. And we were able to read it on the graph. And we came up with 3.33 and 0.47. So we'll look at the book. Yeah, because it involves decimals, graphing technology would be a better solution. And they accidentally gave the wrong answer here of 0.25725, which is what we were already knew, instead of the correct answer. So just there's another example of a mistake. And on to 15. I keep clicking on the calculus book, sorry. Explain the following polynomial equation has no real solutions. Well, it could be because it's well above the... Oh, no real solutions? Oh, okay, because that's an even exponent. It doesn't have to cross the x-axis. You'd have to prove it with graphing technology, but it's a good chance all these wiggles occur way above the x-axis. Not so for odd, though. For odd, you have to cross the x-axis. Let's see if that's true. All powers are even, which means every term is positive. Oh, all the powers are even. So that's something I should have noticed. Because all these powers are even, they're all going to come out positive. Because there's no negative stuff in here, this is going to raise the graph even higher, which means you're never going to have a negative result for y, no matter what I plug in for x. Even x of 0 produces plus 132. Determine, so I should have looked at all the powers there. Determine algebraically where the cubic polynomial function that has zeros at 2, 3, 5 and passes through this point has a value of 122. Okay. This is just kind of working backwards from everything we've just learned. And if I have to stop, so be it, because I'm running out of time here. Determine algebraically. So that means we know the general formula. Y is equal to A, some number we don't know, x minus 2, x minus 3, and x plus 5, because they told us the roots. Now, how do you figure out that A? Well, they gave us a point. I don't know what that has a value of 120 means. But I can figure out the point by putting in 36 for y and 4 for x and solving. So I'm left with 36 is equal to A times 2 times 1 times 9. All right. So I'm left with 36 is equal to 18A, which means that A is equal to 2. So now I can just put the 2 here, and now I've solved that. Now I don't know what has a value of 120. Means. I guess now they want to know, they want me to solve it when y is 120, and they want me to come up with the x, right? Well, to do that, I have to expand it. I get x squared minus 6x plus 6. This is kind of a pointless endeavor. I'd probably just use graphing technology at this point to solve this answer. And then I'm going to use my box technique. To come up with my new polynomial. And the box technique is this. And it helps if you spread all the terms out quite a bit. And then you just draw lines to represent how many terms you're dealing with. And you start by multiplying them individually. So I get x cubed on this one. I get 5x squared. Here I get minus 6x squared. Here I get minus 30x. Here I get 6x. Here I get 30. And then I'm going to notice that these add up. And these add up. So I'm left with x cubed minus x squared, which is minus 6x squared plus 5x. Minus 30x plus 6 is minus 24x. And then plus 30, but it's all going to be equal to 120. When I bring the 120 to this side, I'm left with minus 90 and equals to 0. So now they want me to find out what is the point of x that will create a 0 here. So we're just going to put this aside because that's the equation. And we're going to do this. Okay, so you're dealing with the coefficients 1, minus 1, minus 24, and minus 90, and I'm quite sure we're dealing with something above 1. Yeah. Okay, so let's go right to 2. Nope. Let's go right to 3. Close. Let's go to 4. let's try minus 2. I might have made an arithmetic error, but that's okay if I did. Yeah, that's going to create a negative, so it's not going to be negative, I don't think. Try negative 3. But I don't think it's possible to be negative. No. I would have thought for sure it was 4. Well, you know what? Let's just go back and graph it instead, because I really don't feel like solving it. But so we're talking about x minus 2, x minus 3, x minus 5, and I think it was plus 2 and plus 3. Minus 2 minus 3 plus 5. So we're talking about that, and they're asking us when y is equal to 120. So I'm just going to set the y-axis to be 140. There we go. So it was minus 3 was the one I was looking for, and 5. So I just had to keep going. I had to just keep doing minus 3. And interestingly enough, minus 2 should have worked, so I made a mistake somewhere. Because it's essentially this. And I should have been able to solve for that. So it just goes to show that either I made an arithmetic error or I expanded incorrectly. But that was pretty solvable. Once you try minus 2, you pretty much get it. See what they say. Oh, what was this? Did I skip one? Did they give the wrong? Did they screw up all the answers for this chapter, or did I write them down wrong? Yeah, that's not what I'm looking for at all. Feels like I wrote down the answers wrong. For x is equal to 1, the left side is minus 48. For x is equal to minus 1, the left side is minus 12. That has nothing to do with the question they asked. Very strange. Okay, well, there's only 17. There's only a couple questions left, so. No, I'm not going to bother with this. Well, that's just basic knowledge. Okay, I'll create one with x to the power 4 that has no roots. Ready? Done. Because an x to the power 4 does not have to cross the x-axis. Whereas anything with an odd power, so I'm going to just put x to the power of a plus 12, and I'm going to create an a here, and I'm going to make it 1, I'm going to make it 3, I'm going to make it 5, I'm going to make it 6, I'm going to make it 7. And you can see that all the odd powers must cross the x-axis, which is just common sense, because we know the behaviors of odd powers. Well, I think it would usually have to do with a number at the end that is so huge that you can't really factor into it. So a good example of that would be The question, by the way, is the factor theorem only deals with rational zeros, which means, whole numbers. Create a polynomial of degree, or things that can be divided into fractions. Create a polynomial that has no rational zeros, so something that's an endless decimal. Explain why your polynomial has no rational zeros, but at least one irrational zero. And I think that has to do more with, so we're dealing with a degree 5. So let's just do 2x to the 5 plus 1x to the 4 minus 1x to the 3 plus 1x to the 2 minus x, and then I'm going to create a really weird number here. And as we can see, it only goes through the x-axis once, and it creates, that actually looks like it might be a fraction that's dividable, but so if I just add even more numbers, you're going to get something here that's not a rational number. And so essentially when we have a number that couldn't possibly ever be reached, well, you could also conceivably have decimal places here, which also will produce the same problem. It's kind of hit and miss what will happen, but essentially these numbers are never going to create a nice even number that creates a 0 here. And because it's a to the power of 5, it must cross the x-axis at least once. I don't quite know what they're getting at there. Some of these questions are always kind of pointless. Answers may vary. And again, I think I copied down the wrong answers because that's not what's being asked here. Yeah, I'm actually missing 18 and 19. This is going through 17. So in any case, these last questions are more just common sense about how polynomials behave.